Hello everybody. Welcome to the ENBIX webinar, Key Takeaways from a Net Zero Home project in Central Alberta. My name is Andrea Johansik and I'm a program specialist with the Emissions Neutral Buildings team at Alberta EcoTrust Foundation. And I am joining today from Treaty 7 territory, the traditional lands of the Siksika Sitapi or Blackfoot speaking people, the Tsuut'ina First Nation, the Ayithka Nakota First Nations, and Alberta EcoTrust's main office is located within the city of Calgary, which is home to the Métis Nation of Alberta, Districts 5 and 6. And Alberta EcoTrust does work across Alberta in Treaty 6, 7, and 8 territories, and I would like to take this time to recognize the many diverse Indigenous peoples that steward and care for these lands. And my intention in doing this land acknowledgement today is really to acknowledge directly the harms of colonization towards Indigenous languages, cultures, and knowledge systems, and really to renew my intention to practice decolonization and support efforts in reconciliation. So Alberta EcoTrust is a charity. We've been around for well over 30 years here in Alberta. And we were founded as a corporate non-governmental partnership, and we're best known for grant making, cross-sectoral collaboration, and capacity building in our focus areas, which right now are nature-based solutions and conservation, climate resilience and emissions reductions, and the circular economy. And ENBIX is an initiative of Alberta EcoTrust Foundation. ENBIX stands for the Emissions Neutral Buildings Information Exchange. And just a shout out here to recognize our great funders as well as our broader team. We do have a partnership with SORIA. Our funders are the City of Calgary, City of Edmonton, the Climate Innovation Fund, and the Government of Canada. So our goal, if you're not too familiar with ENBIX, I do recommend that you check out our website at enbix.ca, and you can kind of do that to familiarize yourself with the work that we do. But our goal is really to accelerate building and retrofit practices that lead to an emissions neutral built environment for new and existing buildings right across Alberta. And so we do that, we share knowledge, we aim to build capacity, really foster innovation and leadership, and strengthen collaboration. And we have a lot of different ways in which we do that, one of which is a webinar like this, or case studies and going over great projects that have been done in Alberta. But I'd like to go ahead and introduce our speaker today. I talked about leadership, and Chelsah is a really great example of an industry leader. I've gotten to know Chelsah a little bit over the last few months here, and I'm just really impressed with her passion for this work, and also her patience in educating the industry. So I'm really excited that she's here sharing about a project that she's worked on, which is a few years old now, but I think we still have lots of lessons to learn. So Chelsah Thomas founded Soul Invictus Energy Services in Red Deer, Alberta in 2016, driven by her passion for sustainable construction and renewable energy, and inspired by her experience building Central Alberta's first net zero passive house. Her B Corp certified firm now serves Western Canada for residential energy efficiency. So with that, I will hand it over to Chelsah.
So thanks to Alberta EcoTrust and ENBIX for hosting me today. I really appreciate that. As mentioned, my name is Chelsah Thomas with Soul Invictus Energy Services. And I'm here in front of you guys today to tell you a little bit why I'm passionate about building better and about our project, the Thomas House. So I, along with many of you, in your own ways, are working toward adapting for and mitigating the effects of climate change through sustainable building and retrofitting. And not only do we see a need for building better homes due to increased homeowner preferences and needs, but the industry is moving rapidly toward a net zero future where high performance buildings and homes will be a standard feature across the country. Oh. So I think it's important to understand the whys as to why we're here and what we're doing in our own ways. And my whys include my kids and ensuring that they grow to be healthy in a world that's still livable, clean, and safe. I'm going to talk a bit about my path to what led me here today, and also about my own project, which is a demonstration house and a case study that we conducted, which merges theory with practice. I'll go over some of the lessons learned from that experience, and lastly, answer any questions that you have. So as I mentioned, myself and my partner run Sol Invictus Energy Services. We founded in 2016, and the development of our company was based on the premise of the pillars of sustainability, where we wanted to create a company that focused on energy efficiency and renewables, while also acting as a social enterprise to target energy literacy within my community. This is part of the reason why I'm here today and why I engage organizations like Alberta Eco Trust, individuals and businesses in sharing what I've learned. After completing university, Jesse and I were looking to build our own house, but we couldn't find any local consultants who were knowledgeable about passive homes or net zero homes. And I know now there's an extremely knowledgeable and great network of experts within the industry, but who are passionate about high performance buildings. But at the time, it was incredibly difficult to find anybody to help us. So I ended up taking my own training through Passive House Canada, my Passive House consultant course. I certified as an energy advisor as well through Natural Resources Canada. And we did find help along the way with additional consultants who assisted us with some of the technical details, and of course the sub-trades who helped us with part of the construction. You can see some of the services we provide to homeowners and home builders across Western Canada, as well as designers and a ton of other different stakeholders in the building process. Last year, we became B Corp certified after putting in a lot of hard work and effort during a tough process to provide evidence that we were in fact walking the talk when it came to social enterprise. We are the first certified B Corp in Central Alberta who's a local to Central Alberta. Oh. So although homes today are constructed much more efficiently than they previously were, new actions developed by the Pan-Canadian Framework on Clean Growth and Climate Change include the adoption of net zero energy ready buildings by 2030. The framework also identifies retrofitting existing buildings to increased efficiency standards. This is an important action required to meet national climate goals, and energy labeling provided by certified energy advisors like myself through NRCan's EnerGuide labeling program will be one of the fundamental tools in meeting these energy goals. Passive House, as I'm sure many of you are aware of, is one of the highest standards for building efficiency. However, my day-to-day work involves assisting homeowners and builders in meeting the basic minimum requirements in order to comply with building codes or energy targets for various programs. A recent report by Energy Efficiency Canada stated there's a tension between minimum standard building codes and an implicit goal within the Pan-Canadian Framework to promote market transformation towards highly efficient and low carbon buildings. We feel this effect every day in our day-to-day work. The introduction of NBC 2020's Tiered Energy Code introduced the building industry to different strategies in achieving higher levels of performance. This will help the transition toward higher performance homes for new construction and bridge the gap toward net zero ready within 10 years. However, Alberta unfortunately did not eliminate the previous code pathways, making the Tiered Energy Code optional. So far, we have yet to see any projects be built under the Tiered Energy Code here in Alberta, at least in our circumstance. The tension that Efficiency Canada references on display here, with little incentive for builders to innovate or upskill. And again, this is my opinion. So moving forward, I've always been passionate about sustainability, self-sufficiency, and a holistic practical solutions to environmental problems. When we were looking at alternative home designs as we planned on building our own home, we considered everything from constructing an earthship, which some of you may not be familiar with, but they're very interesting, to gray water systems for our domestic water usage. In the end, we decided to construct our home more conventionally while focusing on the practical application of high efficiency principles in a way that can be replicated simply, cheaply, and using locally sourced materials and expertise as much as possible. There are different approaches to building a high efficiency or highly efficient, high performance house. And the methods identified in this presentation, such as passive house and net zero, are not mutually exclusive, but do approach design and implementation differently. The term high performance will be used to describe either approach interchangeably in order to convey the reduction in energy consumption provided by both of those methods. Going through the process ourselves in building this type of home, we can see that building one is indeed feasible both logistically and economically, even for inexperienced home builders like ourselves to be able to accomplish. So our own project, the Thomas House, was constructed in 2018, located here in central Alberta. It was built using the principles of passive house, topped with solar panels, and generates as much energy as it consumes, making it Central Alberta's first passive solar net zero energy home. There is one other net zero home here. Although it was designed and built using passive house theory, it did not meet some of the stringent passive house requirements, but I consider it a damn near passive house. It's a great example of a high performance home. The reduction in energy consumption is achieved through thoughtful design, insulation, high performance windows, increased air tightness, and the elimination of thermal bridging. We heat it with electric heaters and a wood stove when necessary. We installed a high efficiency HRV, heat pump, hot water system, drain water heat recovery, and other technologies. We have 3 solar systems on the property, one on the roof, one on the ground, and one that powers the water well. The house is served by a hybrid solar system, so it's got a backup battery pack in order to protect the home from outages. Some additional features of the property related to sustainability include a large garden, xeriscaping, fruit forest, chickens, and rainwater harvesting. By conducting site development with conservation in mind, less trees were cut, less land was disturbed than a conventional build may have incurred. We used existing ecosystem services located near the site, such as natural runoff pathways to areas that can manage excess water by absorbing it. Site selection was also important to incorporate as much south-facing glazing as possible for both solar PV and passive solar gains to help heat the home. So one of our first priorities was energy security and self-sufficiency. The second was cost savings and a guaranteed price of electricity. And we knew that part of this process was to build a very low energy home while offsetting consumption, both with on-site renewables, resulting in lower greenhouse gas emissions. This tied into our plan to live sustainably, not only in our home, but in our way of life. And it helped us gain points through our B Corp certification as we work out of our home office. Lastly, we also wanted to take advantage of the many other benefits of building a high-performance home, and some weren't even initially thought of, such as increased health, comfort, durability, and future-proofing. To be self-sufficient and energy secure was one of our top priorities. This was important because we wanted to ensure that we were less reliant on the electrical system. Power outages have occurred in our area for multiple days on end, and severe weather is going to increase. In order to withstand the effects, having a hybrid solar PV system that was both grid-tied and battery-based was important to us. This electrical design of the home included allocating certain mechanical, lighting, and plumbing features either to the grid-tied or the off-grid systems. If grid electricity were to be inaccessible during low light times, the backup solar system and batteries would engage, and appliances such as the heaters, HRV, stove, hot water tank, select lights, internet, of course, would still work. We installed the wood stove for both ambiance, but also because we wanted another source of heat, just in case. This winter, when we experienced the emergency alert regarding electricity conservation, we knew that if the power went out, we would be able to survive on our batteries and wood stove as a last resort. Lastly, having solar energy guarantees our price of electricity over a long period of time as electricity prices continue to rise. So as many of you are already aware, there are many, many benefits of building a high performance home over and above the previous reasons mentioned. Although I appreciate that our motivations to build this type of house may not necessarily reflect the average consumer, more of these benefits are becoming consumer expectations rather than options. These expectations will be driven through technological changes, higher consumer education, a wider range of features marketed by builders, and code adoption. Because our experience of building this house, we tend to attract a lot of clientele who have similar perspectives and want to integrate some of these features as we did into their own homes. So we've lived in our home for almost 6 years. The lived experience has provided us justification in continuing this work for others. It's incredibly comfortable, efficient, and checks almost all of the boxes we had intended when we first planned the design. The home was built with a double stud wood frame with 1-foot thick walls. The windows and doors are Passive House certified, extremely well insulated, and have been designed to let in as much solar gains as possible on the south side and west. The building envelope is also breathable in that we used a smart vapor air barrier system to assist in moisture moving through more effectively and reduce moisture buildup and prevent mold and long-term structural damage. We insulated the attic, slab, and walls 2 times what would normally be installed. The house is very airtight and was tested using a blower door test to ensure that any leaks were identified and fixed before we drywalled. The wall assembly is broken down to show various components here. So we used a double stud wall system, as I mentioned, with a framing filled with R14 Rockwool batt and another layer of R14 batt in between. We chose Rockwool because of its recycled properties, fire resistance, pest resistance, and insulation value. We also insulated with batt as we wanted to take advantage of the sweat equity and did all of the insulating and air sealing ourselves. We chose hardy panels as we wanted to improve the durability of the assembly as we face hail damage and what we would find later on, tree damage during large storms. Luckily, the tree that fell on our house did no damage, but we are currently under a tornado advisory, so fingers crossed. There are some things that we would have done differently now looking back, and some decisions are based on cost and some on inexperience, both for us and our subtrades. We would have definitely installed a rain screen if we could go back in time. The contractor that we worked with stated that a rain screen was not required. However, when I reviewed the material installation specifications, we found out later that it was indeed required as part of the process of installing these types of hardy panels. So the foundation assembly included 2 inches of VPS and 7 inches of Rockwool insulation. It's broken down to show the various components here. This includes exterior damp proofing paired with dimple wrap to help shed water away from the foundation. We installed 2 inches of GPS adjacent to our foundation, which is vapor permeable, allowing any water intrusion to be dried out to the interior. We installed 3.5 inches of continuous Rockwool batt with another 2x4 interior wall insulated with another layer of Rockwool, and the smart air vapor barrier continued throughout the basement. Our header was insulated with 5 inches of spray foam and the cavity filled with as much leftover batt as we can stuff into it, be around R40. The slab included 3 inches of VPS. We initially had planned for about 5 inches of EPS, but didn't plan the footings properly to, Didn't plan the footings properly to accommodate the added insulation. One thing I would have done differently was to install poly over the footings to stop capillary action and moisture movement up into the foundation wall. This is noted in the red line on this slide. It would have been a simple and cheap action to take to prevent further moisture from intruding into the foundation. But I don't believe the concrete company at the time that we were dealing with had even thought about that. The second regret is to not create a thermal break around the slab and exterior foundation wall with the addition of 1 inch or 2 of GPS or EPS. There's a few locations on the walkout side of the perimeter slab that can get quite uncomfortable in the winter time, and additional details and planning would have been required for us to complete that step. So another reason why we wanted to design this house is cost savings, both in yearly utility cost savings as well as the long-term payback period. And I'll be honest, I didn't really know how things would end up over time, as it's difficult to estimate true energy consumption and generation of a home due to changing climatic conditions, occupant behavior. We ended up, adding a few items to our house later on, and utility credit changes, energy cost changes, and other variables. However, after analyzing our costs, credits, and upfront premiums associated to building a high-performance house, I do know that we made the right decision. There were additional costs of the project compared to a conventional build that were incurred in order to meet the higher performance level. This includes more insulation and lumber, higher performance mechanical systems and appliances, additional consulting and testing fees, tapes, adhesives, better performing windows, and the solar itself. The analysis did not include the costs associated to the batteries and off-grid solar or costs associated to rural development. I also adjusted for economy of scale advantages that a builder would benefit from and that we could not benefit from in relation to time spent building the property and as well material costs. So in the summer, the solar system generates more energy than we consume, and we receive credits toward our accounts. Oh, sorry, for some reason I skipped a slide here. There we are. Those credits go toward our energy costs, and we utilize Solar Club pricing through our energy retailer, which allows us to switch between generation and consumption months in order to maximize our credits. During the summer of this analysis, we purchased and sold our electricity at almost 26 cents per kilowatt hour, while in the winter, we purchased and sold at 6.5 cents per kilowatt hour. When we first built our home, our solar credit pricing was at 18 cents, and now it's 30. So it's gone up over 10 cents in only 5 years, while our winter price has stayed the same. I analyzed 2019's energy data for both solar production and consumption, as well as costs and credits incurred through our utility company. 2019 was actually a poor year for generation and compared to other years. But as you can see here, we average out about net zero for that year. Looking at the average charges per month, I compared our build as if it was built conventionally and as if we had met passive house standard. You can see on average our daily costs are the lowest, accounting for the higher performance build and solar energy credits in comparison to the other models as shown. Over time, this project will pay for itself in approximately 20 years compared to the same house, but built to minimum energy code standards. The payback for this project accounted for all fees and energy costs associated to each model's energy sources, as well as grants received during the construction process for solar energy. There are currently no grants for solar on existing homes, although through the federal Greener Homes program any longer, unfortunately. 20 years for us is reasonable, as they like to say. There's no payback period for granite countertops. Now this is also a snapshot in time, and as the energy prices increase, if solar credits increase or the energy system transforms to encourage behavior changes to reduce consumption, the payback period may become even shorter. Since this analysis was conducted, the credit price for solar has increased by 5 cents, which will reduce the payback period even further. I did skip a slide here. I'm sorry, I'm not sure why it's not in my notes, but I just wanted to make a note on the price per square foot. So as you can see here, although our house had a higher price per square foot than a conventional build, it wasn't necessarily as high as a passive house. But I would put it in the range of more of a luxury house in comparison during that time frame. And keep in mind, these numbers are stale. The cost to build has increased since we did all our planning in 2015 and 2016. So just keep that into account when you're reviewing this slide. So some data shows that the average length that a homeowner stays in their home is about 7 to 8 years, with a median length at 13 years. A 20-year payback for us is reasonable, as it is our forever home. However, even if it wasn't, I'd like to view this investment as reasonable, as the upgrades would still be marketable, retain their value, and transfer to the new owner. With homes standing up to 100 years, investing in a better envelope makes the most sense, because it's the least likely and costliest portion of the house to be replaced or updated. Investing in a building that has better building components now translates to cost savings in the future when it comes to investing in building better quality buildings now translates to cost savings in the future when it comes to replacing or updating our housing inventory. The ongoing conversation regarding energy upgrades for new builds and retrofits is something that is happening across Canada. And it's something to pay attention to. I know that there is going to be future accounting taking into consideration what the value is in relation to different energy upgrades for high performance homes and how that can be conveyed when reselling a house. But on our end, one of the benefits of living in the house really can't be conveyed in numbers. Just feeling good, the comfort, indoor air quality, durability, and the sustainability factors unfortunately can't be quantified into numbers. Another goal for the project was sustainability, of course. And I will just verbally speak about this one. So, sorry, that's not showing up there. The energy consumption results of the Thomas House project in this slide are compared to if it was meeting Passive House standard, as well as if it was built to minimum code requirements. The Thomas House performed 71% better than new homes constructed today, less than the 75% improvement of Passive House. It does perform much better than the minimum net zero standard, with a 48% improvement on savings in annual space heat and heating loads, which is a 15% improvement over the program requirements. The building envelope has an 80% improvement over a co-constructed home. If it was to be EnerGuide labeled, it would be consume 0 gigajoules over the course of the year because of the production of the solar system. Oh, I guess that would, I guess this would be the slide that we would want to look at for that anyway. So basically it's going to show how we are performing that much better over a minimum code house. And then if we were to remove the solar completely, we would be sitting at about 43 to 46 gigajoules annually, which is quite a bit lower than the 111 gigajoules of a conventional build if this house was built conventionally. So what I also did was I took a look at, sorry, give me 1 second. For some reason, my, the results of the poll that you did, it's not removing from my screen.
I found this on the web. Forgive me 1 second.
Oh.
And Siri wants to tell me.
I'm wondering if anyone else is having that problem. I did stop the poll, but
yeah, I'm not sure, but I will just explain what's going on in the slide anyway, with that covering my screen. Maybe if I just get out of here, there, that'll work. Sorry about that, everybody. So basically what this is this is a breakdown of the energy consumption of our home in relation to the different features of the home, the space heating, base loads, water heating, ventilation. And you can see that most of the energy consumption is allocated to the base loads. So that would be the appliances, lighting, fans, and anything else that's in relation to outside of the scope of heating, cooling, domestic hot water, and ventilation. With a high performance home, that's where most of the energy consumption is going to be allocated. Because we've reduced the heating and cooling load so much, as well as the other mechanical efficiencies are so high that it's going to look a little bit different from a conventional build, which is here. So if we were to be built conventionally, the space heating is going to be taking up the majority of the energy consumption on the build itself. Now, we also wanted to take a look and see, because we are heating with a strictly electric wall heaters, which is 100% efficient, we wanted to see what sort of opportunities there would be in integrating a heat pump into our house. So a heat pump is something that we did consider initially, but because we were trying to reduce our costs, electric radiant heaters are like $150 per unit, and we put them into each room. And although we don't need a lot of heat, we're able to target the rooms that need the heat at different times, and it just made sense for our family, although not 100% convenient. So during the, if we were going to take advantage of, say, that $40,000 interest-free loan through the Greener Homes program, what would it look like for us to integrate a heat pump system energetically into our house Will we have any energy savings and or any energy costs? So by integrating the heat pump system, we actually would reduce our total energy consumption by about 7 gigajoules. However, this does not account for cooling. So because we do have some issues in overheating, which I'll get into in a moment, I wanted to see if we would have any impact on our energy consumption with the added cooling, which for us would be, although we may not be net zero any longer, it would be more of a convenience and comfort thing. So as you can see, when we add in the heat pump system, the loads change quite substantially, and we do have quite a large cooling load in relation to our heating load. And that's kind of what you're going to see as we move towards higher performing homes. Is we're going to be designing homes more for cooling rather than heating as the loads tend to increase. So another goal for the project was sustainability, of course. So we wanted to reduce our environmental footprint as much as possible. By producing more than we consume for energy, we also reduce our greenhouse gas emissions. And this house is estimated to produce 16 tons of CO2 annually without the solar energy. But since it produces as much energy it consumes, we actually mitigate these greenhouse gas emissions, and we barely produce any. The solar energy installed will save about 3.5 passenger vehicles taken off the road in 1 year, or under 18,000 pounds of coal burned. If this house were to be built by minimum code standard, it would generate 35 tons of greenhouse gas emissions, 7.5 passenger vehicles, or 37,000 pounds of coal. And over the course of 40 years, we will take about 300 cars off the road with our house alone. Although when we built our house, embodied carbon wasn't a huge topic of conversation, we did end up choosing many products with lowered embodied carbon. If we were to go back in time, we would consider different materials like straw as our envelope. There's a great product out there that uses prefab wall systems called Savic Wall Systems here in Alberta. And they've been one of the assemblies that I would have strongly considered. Secondly, we would have considered locally manufactured windows rather than from overseas due to transportation emissions. However, when we did source our GPS and EPS, we got it from Beaver Plastics, which is manufactured locally. And Euro Shield rubber roofing is recycled and manufactured in Calgary. Rockwell Bat, of course, is recycled as well. So no project is complete without reflection on what we could have done and what we could have improved, and this one's no exception. After we've lived in the house for over 5 years, the lived experience is truly the testament to the benefits and results of a high-performance home. This project missed its goal in achieving Passive House standard. On one hand, the results show that economically, meeting the standard could have added further savings on utility costs, but by meeting their air tightness requirement alone, we could have saved $40 a year in heating costs. These would have taken, we could have taken other efficiency measures to meet the criteria as well, but it would have increased our overall build costs as well. After watching a few years of utility data, we know that net zero is not net zero every year. Some years we hit it, some years we've been net positive, and some net negative. And since then, we've added another appliance and a heated chicken coop. So we're trending towards net negative going into this year. And if we ever add on an electric car, again, that's going to be another added consumption device. We do have years where the smoke impedes on our solar generation during the summer, and we've added 2 new occupants to the home, which apparently they use up more electricity. So data tracking over the last 4 years show more recent generation and consumption trends. We use more in energy, but receive more credits back on our bills. As you can see, some years we're net positive and net negative, but we participate in Alberta Solar Club so we can maximize our solar generation. The outlier in 2021 was due to abnormally good summer for solar generation. Oh, and that's not showing up. Oh, there we go. So there's not a lot of, I'll just touch on this. This is just straight out of our utility bills. You can see one of the best months for solar generation credits, and then one of the worst months for electricity costs. Although this is only in the last 2 to 3 years, I have had better years and I have had worse years. I just couldn't go back in time to show what our costs and credit differences are. But one note, when we are building electrically, I do recommend to install solar because the cost of electricity is so high, and even in a very high performance home, you could have up to $600. In our case, I've seen up to $600 for costs for energy fees, which is recouped later in the summer, but it does happen. So there's not a lot of opportunity for theory to merge with practice, and designers and energy analysts having the opportunity to project manage and physically be a part of the construction process. However, this process provided that experience. Unfortunately, we're inexperienced home builders, and oversights that would have been taught by an experienced builder were realized. One example is the additional insulation we had planned to include in the slab, and it didn't fit, so we had to reduce the depth. Another example is that the plumbing and chimney protrusions on the south side could have been planned for more carefully to the other roof orientation in order to ensure that all of our solar could fit on the south roof rather than split between south and west. Another improvement was with regard to the air barrier system installation. The final air change rate numbers were pretty exceptional for first-time home builders. But we could have built tighter if we had conveyed the prioritization of air tightness to our sub-trades more carefully and planned out certain details in relation to the interior framing wall and the air barrier system connections. One other lesson learned is if any of you are interested in buying the Passive House cat door, unless you have real live cats, don't invest the $300 to getting this type of system, because the cats are smarter than I was and were able to break the seals easily, and now it's just sealed up permanently. We don't have any central heating or cooling, so this is something that for your own clients you might want to consider including an air source heat pump or ground source, of course. As it's going to be more convenient and you'll have constant temperature control between rooms. When rooms are not being used, we don't have to heat them, but now all the rooms are pretty much used all the time. And we just keep all of the heaters on at a low rate, and they just maintain the temperature throughout the day fairly nicely. There is great mechanical systems as well that are out there, such as HRVs that are high performance, windows and doors that are high performance, and you don't have to get Passive House certified products to still have great performing systems. I think if we were to go back in time, we would have looked at locally sourced materials and mechanical systems rather than importing our HRV and our windows. Now that we're accounting for embodied carbon into the designs. Unless you're going for certification through Passive House, I would maybe consider other options. Internorm makes a great window and door package as well. So another area of improvement is incorporating higher level of expertise into the design process would have assisted us in achieving Passive House standard at a lower cost. And it's true when they say when you invest in better design up front, you'll save later on. We started working with a Passive House certified consultant later on in the design and construction process, but honestly should have started with that designer from the get-go. Our designer of this house was Passive House familiar, not qualified, and it did lead to some unintended consequences later on. So the previous point is especially important when considering renewable energy. The least expensive form of energy is energy conservation, and by maximizing the energy savings on this project, our solar system could have been reduced even further. The balance between conservation and production should have been weighed more heavily on the conservation side for two reasons: to reduce the costs associated with larger PV systems and mechanical systems, and because roof space is limited. If I were to go through this process again, I would have invested more time in going through a process called optimization and energy modeling. And that's where you can dig into the home energy upgrades and compare the impact of different options, such as the straw wall system versus the double stud wall system that we did. My understanding and ability to analyze the impacts on energy upgrades versus solar costs or mechanical options has also improved. I would have dug in a lot more into determining if we could reduce the solar system size and cost by integrating a heat pump system instead. And I'm not sure which option would have been less expensive overall. Both systems are costly, but I could have eliminated the roof system and did a full ground mount system instead for solar. I would have also compared the performance differences between envelope options, like I said. I'm maybe looking at ICF or other wall system designs, exterior insulation. But at the time, I just was not experienced enough to be able to do that. And I didn't have access to really cool software like Volta Snap that we do now. I now really realize how beneficial energy consulting is during the process of building when considering the house as a system and taking the whole building perspective. So this is an example of optimization. This is basically a comparative analysis of our house, but integrating some different features. So you don't see all of this, but you can see how making slight changes impact the primary space heating loads. And as well, if we were to go through the whole process, you'd be able to see greenhouse gas emissions estimated on solar panels, comfort assessments, heat loss and gain calculations, energy costs, and much more information. So this simulation is done by Volta Snap, and it's something that energy consultants are slowly getting access to. And it's a huge tool and opportunity for us to be able to really fine tune projects, goals and needs, and see what the outcomes are to these decisions. The home achieved all of its other goals identified in the design process, as well as additional benefits realized later on. During the shoulder months of the fall and spring, where sunshine is plentiful, like right now, we never have the heat on, rarely ever. The home is so airtight, and we utilize all these passive gains that we rarely have to turn on any heat, even during the nights. Between April and October, the house is retaining enough heat to stay comfortable. A challenge with high performance homes is a risk of overheating due to the fact that they require very little input energy in order to raise the internal temperatures significantly, which can become uncomfortable. The home did get excessively hot during the first summer, mostly in the afternoon when the sun was on the south and west side. And as you can see, this is just an infographic on how passive gains impact or are impacted by design. Passive ventilation techniques were applied as much as possible, which included opening windows for cross breezes or opening a downstairs window and an upstairs window to utilize stack effect and natural ventilation. Utilizing the cool night air in Alberta is an excellent form of free cooling. However, further analysis should have been conducted in order to get a better understanding of our cooling needs. A simple calculation or a simple design solution is to adjust the overhang length on the south side as to not hinder wintertime solar gains, but block summer solar penetration. Additionally, like I said, a heat pump could be installed, although at a higher cost and energy penalty when accounting for only cooling. So we decided to install removable sunshades on the south side deck, which provided a shaded area on the patio in the summer while ensuring that the precious wintertime sun is still accessed on the south. You can see the energy consumption. Oh, and actually we've already went through the energy consumption results, but the total energy consumption of the house, again, is net zero while accounting for our current energy consumption and generation capabilities. But it was our personal attempt to do better in this world. It opened up a lot of opportunity for us to continue to work in the community and better understand home energy and renewables, as well as help our own clients in meeting our own energy goals. And yeah, this is the end of my presentation. I really appreciate you sitting in on it, and I'd be happy to take any questions. And if you want to reach out, these are our socials and contacts.